Welcome to Spring LIB.
Hi everyone, so what we have here is a roller coaster track that is defined by a spiral, and that's given by r is equal to 0.75z, theta is equal to negative 1.5z, where r and z are in meters and theta is in radians. We know that theta dot is 1 radian per second, and that's always maintained. What we're asked to solve for is the Fr, F theta, and Fc, so the components of the reaction force in the r, theta, and z directions that are exerted on the car by the track when z equals 6 meters. And as stated here, the mass of the passengers in the car is 200 kilograms. And the way we're going to go about solving this problem is by using our knowledge in the normal, basically the r, theta, and z direction, so normal and tangential forces, normal and tangential motion, and by using Newton's second laws to develop equations of motion to solve for these forces. So let's go ahead and get started. First of all, we know that r is equal to 0.75z. Therefore, we know that r dot, clarify that, just make this r. We know that r dot is 0.75 z dot, and that r double dot is equal to 0.75 z double dot. Next, we know that theta is equal to negative 1.5 z. Therefore, we know that theta dot is equal to negative 1.5 z dot. And then we know that theta double dot is also equal to negative 1.5 z double dot. What we can do now is we can say and go ahead and solve for our actual theta dots, z dots, and z double dot. So we know that theta dot is equal to 1 radians per second, which is given to us. And that's equal to negative 1.5 z dot. Therefore, we know that z dot is also equal to negative 0.67 meters per second. And we know that z double dot is equal to 0. Next, what we can do is we can go ahead and solve for our r dots. Because we know at z equal to 6 meters, r is just equal to 0.75 times z. So this gives us r is equal to 4.5 meters. We know r dot is then equal to negative 1/2 meters per second. And we know that r double dot is equal to 0. And theta double dot is also equal to 0. So now what we can do is we can go ahead and solve for our accelerations in the tangential, theta, and z directions. So we know that AT, which is equal to AR, is equal to R double dot minus R theta dot squared. And this gives us negative 4.5 meters per second squared. We know that A theta is equal to R theta double dot plus 2 R dot theta dot, and that's equal to negative 1 meters per second squared. And that AZ, which is equal to Z double dot, is just equal to 0. Now what we can do is draw a free body diagram in 3-dimensional space. So here we have our Z direction, our R direction, and our theta direction. And here is our cart with the passengers on it. So here's our F theta, here is our FR, and here's our FZ. And the only force that we have acting on it other than these forces is our weight force, which is acting directly down through the z-axis. So now what we can do is we can apply Newton's second law and say that the net force in the r direction is equal to m times AR, and this is equal to FR, and that's equal to 200 times negative 4.5, because that's what we had for AR, and this gives us an FR that's equal to negative 900 newtons. So that's one part of our answer. Next, what we can do is solve for our net force in theta. So we know that the net force in theta is equal to m times A theta. So therefore F theta is just going to be equal to m times acceleration in theta, which we know to be negative 1 meters per second squared. And this gives us an F theta equal to negative 200 newtons. That is another part of our answer. And lastly, solving for Fc, we know that the net force in Fz is equal to m times Az. And as we mentioned, the only force we have in the z direction is the weight force. So we know that Fz minus mg is equal to 0. Therefore, Fz is just equal to the weight force, which is 1.96 kilonewtons. And that's our final answer.